In this video, I want to talk more about the serial interval, and specifically I want to explain how the serial interval can actually be negative. So let's just remind ourselves what the serial interval is. The serial interval is the amount of time which elapses between a first individual becoming symptomatic after they've been infected with the disease, and then a subsequent person whom they infect becoming symptomatic. So now I'm going to explain how this quantity can actually be negative. So we imagine that there is a first individual and they become infected at a given time point, which I just denote here. And then whilst that individual is asymptomatic, or actually pre-symptomatic technically, then they go on and they infect another individual. So we're imagining here a disease which can be passed from person to person. And then this other individual has a very, very short incubation period, a very short amount of time which elapses before actually they become symptomatic. So they become symptomatic at this time period here. And because that incubation period was so short, actually it means that the appearance of symptoms in the second individual have occurred before the first individual has themselves become symptomatic, which occurs at some later time point. So now if we take the strict definition of what a serial interval is, it's the amount of time which elapses between the first person showing symptoms and the second person whom they infect showing symptoms. And here, that is actually a negative amount of time because the second person's symptoms have appeared before the first, and so we get a negative serial interval. But we notice that the generation time, which is the amount of time that elapses between the first person becoming infected and them infecting a subsequent person, is positive. And the generation time is always positive, because it represents a degree of causality. The second person cannot become infected before the first. If it was the other way around, then it would be the second person that was infecting the first. And the serial interval and the generation time, they're not fixed quantities and they vary between individuals. And they vary potentially over time. And so we can imagine a probability distribution that describes these quantities. And so I can imagine here, if I plot on my bottom axis days, then the generation time is always greater than 0. So I can plot on here a probability distribution that might represent a generation time that looks something like this. So this would be the generation time distribution. And it may be the case that the serial interval distribution is very, very similar to the generation time distribution. But for example, if there's a lot of heterogeneity in the incubation period across different individuals, it's possible that the serial interval can actually be negative, as I've indicated here, and so the serial interval distribution may look something like this instead. And it's worth saying that in, for example, COVID-19, interventions such as lockdowns essentially meant that people were spending longer in their houses, cooped up with the same individuals, and that actually may hasten the serial interval and shift it towards the sort of negative end of the spectrum, as I've indicated here. So again, the serial interval and generation time, they're not really fixed quantities, they vary in response to interventions. But the serial interval can be negative, whereas the generation time is always positive.